Okay, we're in the last part of section 12-3, the segment of the circle. So we've talked about the area of the area of a sector, and that's a piece of pie. And we've talked about the border of the sector as a piece of the circumference. But now we want to talk about this little piece you get when you have an arc and then a chord. And it's the space between those two. So the way you find the area of that is you take the area of the whole sector, which is a fraction of an area of a circle, and you subtract away the area of the triangle made by the central angle and the chord. So let's try that in GeoGebra. This one actually gets pretty tricky in GeoGebra, so we'll play with that and see how that goes. Let's see, open new one. I'm not going to save this one. I already did. Okay, so I need a circle. I need more points. I'm going to need a radius. I'm going to need a sector. It says center point, then 2 points. Draws me a really nice sector. And then I'm going to need the chord the segment, the chord that connects these two. So then now I've got this triangle defined here. And as I move this around, it just makes sense that the area between the chord and the arc is the total area of the sector minus the area of this triangle. Okay, so the total area of the sector I can find easily enough. Area of D, and that's the sector. Oh, it didn't show it. Area of D, the whole sector, 7.29. Let me go ahead and put the angle in there. Select the 3 points. Okay, that's an 89.44, almost 90. Let me make it 90. Now this area should now be 1/4 of the whole circle area. So let's go ahead and find the whole circle area. And all I have to do is type in area. Circle area. I don't usually do it this way, so we'll do it the other way. We'll say area of circle A equals pi r squared. So bring up my keyboard, click on my pi times the radius, which is dA, and I look up here to see how it's written, distance dA, and that's what I type in, distance dA. And squared, so I click on the squared. Okay, so that's my area. So it's almost 30, and 1/4 of 30 would be 7.5. So this is just under 7.5. So that makes sense that this is 1/4 the area of the whole circle. So now I'm going to go ahead and find the area of this triangle, and there's a really nice function for that. Area, oh, I think I can take it back. I'll type in down here. Okay, so area, and they say I can do a polygon, and the polygon here is the triangle ACB. Oh, it didn't like that. Sorry, I didn't find it. Okay, I can, oh, right, I can come here and declare a polygon A, B, C, back to A. Now it knows this triangle, and it's calling it T1 for triangle 1. So now I can say area, and I can say T1. The area of T1 is 4.67. So the area of the whole segment we found already was 7.29, and the area of T1 is 4.67. So to find the area of this sliver in here, we just do 7.29 minus 4.67. segment BC equals, and it's going to be area of D. I can go up and see what they called that. I don't know, D, circular sector. So that's the letter D. Oh no, area of D is A. So I can type in an A equals A minus, oh, and this might give me some problems, so just work with me on this one. A minus the calculated area of the triangle, which is E. Okay, so A minus C, 2.67. So 4.67 minus 4.67 is the area of the triangle, and 2.62 is the area of the segment, and that, just do it correctly instead of just estimating, 2.62 plus 4.67 equals 7.29, and the area of my whole sector is 7.29. So there you go. The three add up. You can download this as an image. Area. You can save this. Then go ahead and share. Copy that link. Go to your slides presentation. Here's my sector of a circle. I'll go ahead and insert the slide, the duplicate slide for area of a segment. Insert image, upload, 12-3, area of segment. Crop that. My text really works, so I'm just going to crop that right out. Make this bigger. Okay. And then explain, oh, and put the link in here. If I click on here and click the pencil, it will let me delete what was there and add in the new one. And then I can come in here and explain that the area of a segment equals, and let me get rid of this 1, 2, 3 part, equals area of sector, which is the piece of pie, minus the area of the triangle. Now, the last thing I wanted to tell you is in this section, to do the area of the triangle, you need 1/2 base times height. The textbook will make it easy for you. It will give you a 90-degree angle so that you can easily figure out the height, or it will give you a 60-degree angle so that you can cut it in half and make a symmetrical triangle. Look for that. Later on this chapter, we'll find easier ways to calculate the height. There are also other formulas that are pretty easy for calculating the area of a triangle if you want to look that up on your own. One uses sine, and the sine trigonometric ratio, and another one's called Heron's formula, but you'd have to know all three side lengths for that. So the sine formula is actually really easy in this case if you want to look that up. Okay, good job. I'll see you next time.